everyone. My name is David. I'm going to be talking a little bit about a couple studies I've been doing on after-school and science learning, particularly with girls of color. Particularly, a lot of my research focuses on how do we support girls of color to see themselves as scientists, to see themselves as people who can do science, produce science, and see themselves to possibly even see a career in science. So a little outline of my talk today. I'm going to first talk about what is science. A lot of us have this idea of what is science, but I'm taking on a different perspective that's a little bit more flexible. I'm going to talk a little bit about my past work in a computer science club, where I saw a few of our students see themselves possibly as computer science people and as scientists. And then a little bit of talk about a shift in my thinking after doing this study, and my current work, which is with what I call the Super Science Squad. So just to give you a little bit of context of the work and the talk, I did the first phase of my research was an observational study within the computer science club. Then I actually started implementing my after-school program. This was last year. And this year I'm doing another implementation. So this will kind of give you a context and a timeline of where the data's from and also where a lot of my thinking has changed and started shifting. So what is science? So think back to, I work with fifth graders, so let's go back to fifth grade. What do you think science is? Where do you remember doing? Fifth grade, you're probably focusing on energy, you're focusing on ecosystems and the solar system. So just hold that in your head. But I also want to talk about, in particularly, who is positioned as successful in STEM. NSF always releases a report every other year talking about who is pursuing higher ed STEM degrees, who's enrolling PhDs. And it's always that Hispanic women are underrepresented in science and engineering. But there's a disclaimer from that report saying we're not necessarily making any policy recommendations. We're not saying that, certain people are not well equipped to pursue science and engineering, but in fact, these are just who's graduating and who's not. But what really happens is we get these ideas of, okay, there's underrepresentation of girls in science and engineering, so let's do these things. Let's talk about how girls should be the next Steve Jobs. They should do science, including, I think that's a lip balm kit, right? These girly things of what it means to do science, and it's very limiting. As you see, it's very bright and pink, and that's one way of thinking about doing science. Is it problematic? Through all those specific examples, I saw those kits, those books. It's really framed around girls need to be more engaged in science. And that they need to be more than just a stereotype, more than just, someone who does lip balm making. And that they need to be more prepared for STEM, and they need more STEM role models. I always find that really interesting. How do you find more STEM role models if girls of color or women of color are not in STEM? Where are their role models if you're trying to find role models? That never made sense for me. So then I keep wondering, why do we keep framing that girls, particularly Latinas, are deficit? Why are they always needing to do more, needing to be more engaged by buying this product, or need to a specific curriculum that's geared towards pinkness or whatever you want to call it? And so I want to problematize that framing that Latinas actually don't have enough. They don't have enough cultural capital, positive belief system. I don't want to keep saying that girls don't like science, or that they don't know a computer scientist and have that social capital, or that they don't have the economic capital, the money to purchase these kits such as robotics and computers. Instead, I want to talk about what are some of the things that they have and the things that we can leverage. Particularly, I want to look at these things called cultural practices and resources, which include knowing, being, and doing from their day-to-day routines. What are they doing every day that could be applied to science? What is the history of that person, their family history, their personal histories, and their lived experiences too? I think that using this perspective is more expansive because we're not talking about what people don't have, but what people actually do have. And this is actually really, really hard. Imagine if you're in a classroom, that fifth grade classroom with, 40 kids? How do you learn about each individual child to talk about their lived experiences? It's really, really hard to do. And so that's one of the challenges, and I think through the research I'm doing and some of the programs I'm implementing, hopefully I think there's a way to be able to really acknowledge these rich, diverse cultural resources and practices. So now back to fifth grade science. What is science learning? So how many of you thought it was memorizing facts and equations? Hexane flip anyone? No? A little bit, right? You even have a book for confusing science terms. That's how confusing it is. You need something to supplement the glossary, right? But I want to reframe that science learning as not just memorization and facts and equations. I want to be expansive about it. I want to think about science as not only consuming science, meaning we're learning about it, but also producing it. What kinds of meaning-making are happening when we learn science? How do we know more about ourselves and the world? And I also wanted to redefine it as a social activity that's culturally based, that it's not in a single laboratory with a single person, but it's the fact the relationships we have with one another, the relationships we make with our data. And I also want to redefine it as actually creating change, reducing, reusing, recycle, for example, and interacting with the world that we see, right? We're making all these claims about the world, about different, especially if you're in natural sciences, what about the world are we making claims about? And doing so, I want to call this the practices of science, how people understand, use, and produce science in different domains of their lives, right? From homes to your city to your school. All these ways in which we can think about science as not just memorization, but ways of knowing, being, and doing. And so, for me then, equity-based science learning is the process of making meanings, those practices, forging those relationships between different settings and people, and ultimately developing a science identity. You don't have to necessarily be a PhD candidate in a science major to be a scientist, right? I want to think about how people engage with the practices of science in their everyday lives. And so identity is really, really complicated, right? How do you capture and measure identity through studying identity? Okay, let me start with this. Think about who you are in this moment. Think about who you were 5 minutes ago. Our identities are always shifting. So one example I pulled up was from Alice in Wonderland, where the caterpillar asks, "Who are you?" Alice responds to, "I hardly know, sir. Just at present, at least I know who I was when I got up this morning, but I think I've been changed several times since then." Right? When you leave the room and you're with a different group of people, you might engage in different types of identity work, right? You might be someone who's a leader in your group, or here right now you're playing this identity of a participant in a group audience, right? And so it's really hard to capture that then. So how do you know who one person is at any single given moment? What I do is then I look at identity work through critical events. So the moments of time in which those practices of science are happening and ways in which girls are engaging in science in that moment as a chunk of events rather than an endpoint. So I'm not comparing and contrasting from like pre to post, but seeing the gradual development of processes, the ways in which identities are stabilized or destabilized at any given moment. And so I want to talk a little bit about how I saw this in a computer science club I was at. So in this computer science club, I was just basically hanging out with the students. It was actually through another research project on a citizen science project, but I was invited to go to their computer science club. And through that research, I came up with this new concept of identity resources. So how do we take what I said, those cultural resources and practices, and leverage and recognize them to be a part of someone's identity? So I think about it in two parts. First, resources from other settings are leveraged, and for doing that, we're acknowledging that the students that we work with have lives outside of school, that they have other activities they participate in besides in school. They do stuff after school, they do stuff at home. And once you leverage that, you can recognize them, right? You recognize that as being a legitimate resource in participating in science, right? And it really validates and celebrates their histories and their experiences. And so through these two processes of leveraging and recognizing, we can see identity resources generated and development of a STEM identity. And so like I said, I was hanging out, geeking out across these different settings, right? From school, computer science club, and family science. And that's where I saw those different cultural resources and practices across setting come through, particularly in the computer science club. So to give you an example of the day-to-day activities. So during school time, there was a science project I was hanging out with there. Computer science club every week, and just since I was there at computer science club and the school, I got pulled into really random things. So open house night, right? People were saying, "Can you help us with open house night?" Right? This is funny. I have a chocolate fountain, and so they thought, what if David brings his chocolate fountain in, also sets up a station for what they're doing in computer science club and in the school setting? Maybe that can help bring some of the parents over, and we can, increase the number of people that come. It was also really weird too. We also had a field trip. So we didn't have any money for a field trip. And so miraculously, after asking some people, we found $20,000 laying around, and just being in that setting and knowing different people, it was just an interesting sight to be able to see how all these different settings connect together, but only because I was there for long periods of time too. So when people ask, how do you know what resources and practices you can leverage, I don't know all of them, but I can certainly see a lot of them because I was there for so long. And let me tell you, $20,000 is really not too hard to find if you talk to a lot of people and say hi to a lot of people. So I want to talk about one of the cases where we saw a girl, Juanita, generate identity resources. So her resources were leveraged and recognized. She's 5th grade Mexican American, and in March, the teacher, Ms. Frizzle, said, I'm not sure she's a science person. She does this thing where she raises her hand this way, right, instead of this way, right? Like, she's trying to hide, basically. And then I saw her attend computer science club from March to June, and in June, she said, I can see myself as a computer scientist. I'm going to walk you through some of the moments of identity work, which I call critical events, in which I saw leveraging and recognizing resources. So the first critical event happened when reading resources was leveraged and recognized from home to after school. So in the after school club, they were working on block coding for Scratch. I don't know if you've done that before, but it's basically computer coding, and you drag and drop different commands on there to form a sequence. So when you click the red flag, forever, you'll move 15 steps, turn around 90 degrees, and turn around 10 degrees, right? And so in this project, they created digital stories, right? How do you tell a story at the beginning, middle, and end through computer science? And from this resource we saw reading, Juanita was actually the top reader in the whole school. Remember, what's it called? When you have to take tests about reading academic reader points, you go on the computer, talk about the summary, and you get points. So she was the top one in the whole school. And in the library, in the cafeteria, basically everyone was right here. She was all the way up here in terms of how many points she got. And that's where I saw that reading resource become an identity resource. And in another one too, I saw in-school quizzes being leveraged and recognized from school to after school. So during the school setting, they all have laptops, and one of them, think about iClickers, right? Basically, they ask a question on top on Kahoot, and each of the symbols is an answer, right? Like A, B, or C. So it could be like, how much fun are you having, right? The red would be a little, the blue could be a lot, things like that. And so what happened was I never saw her score a lot of points on Kahoot in school. So what I think she did was, she said, I basically made an impossible quiz because those quizzes in school are impossible, so I'm just gonna make my own quiz so no one else can get points too. So in this case, she recreated the quiz, mocking the quizzes that she does in school. So this one was, oh, look, Count Dracula. Which one? Oh yes, he's a sexy one. Sorry, I prefer lemurs. It's very similar to the Kahoot program that she did, and she actually coded that Count Dracula quiz all by herself through the same Scratch program. And so in comparison, I want to talk to Alma, where we saw missed opportunities to generate identity resources. 5th grade, Mexican American, same classroom. She didn't attend computer science club, but she always went home and drew. She always went on her tablet and animated all the time. And in March, the teacher said she's a top science student in her grade, which really contrasted in June, where she sees science as boring and wants to be an animator. And I purposely put quote, stars on animator because I remember I said, I don't necessarily think people who see themselves as scientists need to pursue science careers or science PhDs or science degrees. But you can see the affect. Science is boring, I don't want to be here. There was a shift in terms of the ways in which she is engaging with science that was more than just, I don't want to do science as a career, but it was more, she saw it as boring, right? There was an affect difference. And like I said, she always goes home and draws a lot too. And we saw missed opportunities in which these art resources were not leveraged and recognized. They did not become identity resources, right? So for example here, this is transpiration, right? Drawing on the board. And literally for 20 minutes in the data, we just saw her draw that, and that's it, just stared at it, didn't do anything on the worksheet, right? That was a missed opportunity in thinking about how can we leverage a lot of the drawing resources that Alma had to be able to engage more deeply in this activity. Same thing with this one too. They're doing a water filter where they cut a soda bottle and invert inside, and they place different rocks and sand on top to see how it would filter water. The way her water filter was drawn, she literally drew every single pebble to a grain size, and the large pebbles really big, shaded each pebble. But she was never recognized for that work, right? No one ever said, wow, that was a really good filter drawing. That really helped me understand, how you designed your filter. Instead, basically, this was never recognized. It was never seen as drawing was not seen as a legitimate resource of doing science. And so, in the end, I did all this analysis and started thinking more about the claims I make, right? We had this one girl, right, Alma, missed opportunities, right? Another sad story. And then we had Juanita, where we saw a big shift in science identity, big shift in STEM engagement, right? And we're always saying, okay, so we learned best ways, we've learned something about how to support girls, leveraging and recognizing, so what? And so, this is a question I pondered for a year, right? I kept getting asked, do you want to conduct research and write a sad story again, like Alma, or do you want to do something about it? Do you want to actually take what you're trying to claim and actually implement it through some way? And so, through my analysis, I was thinking, okay, so how do I actually improve learning environments for girls of color to see themselves as science people? So the first design claim that came from the data is being open and flexible in your activities where multiple entry points can be used to leverage resources. So if you think about an activity that's very, how to describe it? Like the drawing activity. There is only one way in which Alma could have entered into the activity to sustain her STEM engagement, which was through drawing. That was only one way. But for Juanita, the girl in Computer Science Club, there was multiple ways for her to enter in, right? Digital stories was one, making computer science games was one. There was multiple ways in which her different resources come in, because you can code anything in computer science, right? There's multiple stories you can tell, there's multiple activities you can do compared to just drawing transpiration. So if you have an activity where multiple people can come in and be leveraged and recognized in their resources, I think that's a better way to design a learning environment in science education. My second claim is thinking about sequential opportunities. I think about those leveraged and recognized resources as keys to opening up future opportunities in STEM learning. We saw with Juanita, right, through Computer Science Club, she was able to engage differently in computer science different ways over a long period of time. And that supported and maintained her position as a science person. But compared to Alma, right, all those times she wasn't recognized for her work, it kept creating barriers for her to want to see herself as a science person. And so, like I said, I've been thinking a lot about this bridge to research and practice. And one thing I thought about is, a bridge is very tiny. Right? You think about a bridge, there's only a certain number of people that can literally be on a bridge. So I wanted to think more about research and practice blurring together as a different space. Instead of a bridge between research and practice, why don't we create a new setting in which you can do both research and practice together simultaneously, which is how I started running this after-school program. So in this program, I've been running it for the last 2 years, and it's from all the design work from my first study with the Computer Science Club. And so examples of curriculums are ecosystem video logs, where I ask the students to make a vlog about their school as an ecosystem, what are some of the consumers, non-living things, and how do they interact. And we get things like these video logs about kids seeing what's in their school ecosystem, right? They see cats and mouses, they also see things in the kitchen. And for this research, I'm looking at how school and home become identity resources. So you have the school ecosystem, the school culture in which they're a part of, and this home-based practice, which is apparently watching a lot of Jake Paul videos. So that's how we got to all these vlogs, because literally they were making vlogs about their schools and talking about what are the non-living and living things, and being able to layer those home resources like watching YouTube videos in their STEM practices. And then I follow up with what are the problems of the school ecosystem and what are the design solutions, and they engage in the engineering design cycle where they find a problem in the ecosystem and try to design a solution. How can they actually engage in the practices of science to make that actual change in their community? And so for this one, we have the school playground. Problem, the kids are getting sunburned, they're getting stabbed by the wood chips on the floor, and people are getting hurt by one of the jungle gyms. And they actually did their own research, collecting data on students. So 16 out of 16 students want no more wood chips on the floor. Instead, they want plastic foam. And they actually came up and researched what are the materials we can use, how can we actually build it, and pros and cons too. And they actually presented it to stakeholders, the actual principal of the school. And now I know from the newsletter that they actually did replace the foam, right? And they wouldn't have known to actually make that change without some of the research that the kids actually did. And so my takeaways. Science is about engaging in the practices of science and not just about memorization, about how we want to be able to make and produce and consume knowledge. Also, this idea of leveraging and recognizing identity resources is expansive ways of thinking about how to support kids in their STEM engagement. And I also want to think about reimagining the new spaces of engaging with research and practice. That it's not a bridge. That bridge is very tiny. We should be really working on creating a space where we're doing both research and practice at the same time simultaneously. Thank you for your time. It's my contact information, and I'm open to questions.
Questions for David?
I'll ask one, just to help.
Yeah.
Hopefully you'll view it as help, David.
Yeah.
So in terms of the conceptual frameworks that are driving some of this work, have you looked at the work of Norma Gonzalez and Luis Moll, Kathy Amante around the funds of knowledge stuff? Because it seems to fit very directly into the things that you're talking about and share some of the similar ideas that you share with that.
Yeah. So with the funds of knowledge framework, I know that particular study was really focused on things outside of school, right? The home life. And there wasn't much into thinking about in an after-school setting, what would that really look like? And another one, so with the theoretical framework I use, which is social practice theory, I look at the actual interactions that happen in the moment and the shifts in identity during that time. And to be able to do that, I have to really rethink, okay, what are they actually doing in their day-to-day lives? Not just the funds of knowledge, but they're things they're actually engaging with. So they're both very similar, but to be able to actually analyze the data, I had to look at the social practices and the types of interactions they have in the moment.
Yeah, well, I thought it would supplement a lot
Yeah.
through the whole environment because, as you're aware with the funds of knowledge, it draws upon their own sense of individual and family and cultural identity in the study of the topics too. So to sort of layer that with what you're doing in terms of in the moment, it might be a really powerful way to think about that, especially if you can connect what you're doing in the moment with what they do with their families.
Yeah.
Once they leave that space and place, it could be a nice,
Yeah.
powerful compliment, it would seem to me.
Yeah. It's really hard in the home life, I think, to be able to capture those funds of knowledge. So I've been thinking about different ways to be able to because home life is really awkward, right? You have to go to their house and like, what is available and not available to? So I think thinking about funds of knowledge and to be able to think about what may be happening in the home life too would be very helpful. So yeah, thank you.
You've had your Super Science Club for 2 years now?
This is the second year it's implemented.
How has the enrollment changed from the first to the second year?
Enrollment in what sense?
Just like the number of students that are taking part in the after-school club.
So I only work with fifth graders. So once they move on to sixth grade, I don't see them anymore just because I don't have the capacity and the undergraduate research assistants to help me with that. But before the first year, it was a different setup. We had 2 one-hour blocks. So we saw 30 and 30, so a total of 60 per week. But now we have them for 2-hour blocks, but for 30. So longer periods of time now, but with smaller amounts of kids. Yeah.
Do you follow up with the students afterwards, since you said that they moved from fifth grade to sixth grade, and have there been any positive results with what you do in your after-school program?
So the school is K-8. So actually, when I'm running the second year of this current year, those fifth graders had last year actually just outside. So we've been talking indirectly just as we're passing by through, and we're starting to do follow-ups with the sixth grade teacher because the sixth grade teacher actually teaches 6th to 8th grade science. So I wanted to be able to understand a little bit about their school life. So we're collecting the data on that. In terms of their shifts in identity, I'm not particularly sure yet, just because we're still collecting that data, and they're in 6th grade right now. But we can follow them up to 8th grade, basically.
Do you have specific follow-up ideas in mind? Like, are you going to follow up all the way to 8th grade? And by 8th grade, sort of what do you expect to see?
So it will depend on each individual person. We had in our data set one child who, it was really odd. She was never recognized for her resources by another student. There was an interesting power dynamic where we had one student who always was the one to raise her hand, always the one to volunteer and be the spokesperson for her group. And I think in that way that might have impacted this other girl and her identity resources, because we can never, it was really hard to recognize those resources because we had her peer who was always the one who was very talkative. So I think in that sense, I'm just with a hunch, I think that might have been destabilized when I look at the data just because of the power dynamics within the classroom and then within the group too. The other girl, the one who was always talking and always raising her hand, actually I think she might have moved, so I don't know if I can follow up with her. But the other people have been pretty stable from what we've seen, and from when I talked to the 6th grade teacher, it seemed like they were stable too. When I talked to them about, because they'll see me literally through the window, and they're like, oh, they're making their video logs about the school now, or they're making the posters now too. And so from that, it seems like there was some sort of stability from what we saw from last year. Yeah.
So one of the girls participated in your computer science class.
Mm-hmm.
Was that a that's not the same as the super science squad, right?
No, that isn't. That was. Mm-hmm.
Okay, so maybe the super science squad, how are the students selected to participate, or do they self-select, or is it a whole class?
Mm-hmm.
Who gets to participate?
So the after-school setting in general is run by the school. It's a charter school, so they run their own after-school program. If you are not doing academically well in math or English, you'll basically be put in, what do they call it? Basically mandatory after-school, where it's basically drill and kill. And you do not get any science, because science is considered an enrichment. And so if you're doing well in math and science, in math and English, you get to be a part of the program. So there is a self-selection issue in terms of academic achievement. And just basically, it was so hard to be able to do multi-site settings, to be able to do the IRB for both home and school, because that would basically mean one IRB with 2 different programs. But because this after school was nested within a school, it was a lot easier to be able to gain access. And also too, from what I've noticed, just because the girls are doing academically well in science may not mean they have a science identity too. So like that girl, the drawer, Alma, she was doing very well in science. Like the teacher even said she is a top student in science, but we can still see her not having a science identity because she said she hated science too. So I think the self-selection in terms of the academic achievement may be an issue in recognition, but I think it's still an important thing to study.
All right, so we're going to move on to our next speaker. Thank you, David.
Yeah.